In this lesson we will talk about joints, and joints are the tool inside Cine4D which we will use to create skeletons and various setups, and we will use those skeletons made from those joints to control polygon objects. And by controlling I mean deforming them the way we want. So if you will ever want to rig something, create a virtual puppet or a character, or human character, or any other character, anything that should be deformed, use joints. They are the most flexible and versatile solution. But before we do that, we have to understand a few basics, and this is really important. Do not skip lessons in this training. This is really, really important. I want to show you something that is quite often used in rigging, and it's called an IK chain. It may be a little bit technical, but rigging it's a bit technical by its nature, so there is no way around it, unfortunately. So let me create that simple joint chain. I'll rather go to my side view, something like this. And here under character menu, we have a joint tool. And if you try something right now with it, like pressing your mouse button, nothing will happen. And the reason for that are these modifiers here. So if you expand this guy a bit, the default for that left mouse click is the move joint. And if you press the control key, you can actually draw them. So let's say I want to create a straight free joint chain here. So let me enable some snap settings here. It's exactly the same like pressing the P key. So we'll enable snapping. Disable everything except this grid maybe. Just zoom out a bit. I will be able to create joints that will be snapping to this point. So let's try something like this. And you can see it perfectly snapped to these crossings. And I will disable snapping. Let me go to my perspective view and I will show you something right now that is really interesting, and it will pretty much explain once again that z-axis rule inside Cine4D. Disregard what I'm going to do right now, because I will actually create a simple IK chain, and we will talk about IK, so don't worry about that. So I want to show you the problem you can have if your z-axis is not pointing down the chain. Let me select this topmost joint and move it just a bit, and watch what happens. The axis goes wild. Let me undo that, and this is not good. You don't want this to happen when you create characters and bind that skeleton to your mesh, because you will have twisting and geometry will jump and all sorts of bad things. You generally want, almost in any case, for each of these joints to have its z-axis pointing downwards. There may be a few cases when you reach a really advanced level, when you really know what you're doing, and you will set up something different than z-axis pointing down. So let's just undo until we reach the moment we have no IK chain, so I can explain that a little bit better. To prevent this kind of popping and really bad behavior, there is a nice tool here under character menu, and it's called Joint Align tool. And there are many settings here, and unfortunately you will have to deal with that, because in rigging those commands, those tools have pretty much a multitude of settings. And rigging, it's by its nature, it's a bit technical, but it can be understood without a problem. If you really understand and fortify the basics, that is really important. So leave the default values for now and hit align and watch all these guys. What will they do? So align, and you notice that you have to select just the topmost joint. And if you have this children enabled, then all guys will orient in relation to this joint. Now we have all joints pointing downwards, down the chain with its z-axis. So let's create that IK chain, and we will explain what IK chain is. I will just move this this world grid. So let me do just that. I will filter it out here, so uncheck this world exit. It's kind of in the way. So let's create that IK chain, and usually when you want to create the IK chain, you will select the boundary joints that will define that IK chain. So you will select the topmost joint and the bottommost joint. In this example, I could go only with this one selected since there are no joints beneath joint 2. But if you have other joints down the hierarchy, you should create a boundary selection. So IK chain will be made from this guy to this guy. So instead of talking, let's just do that. So go character, command, create IK chain. And you will notice two things happen. First one, you got an IK tag on this topmost joint. The second one is that you got a completely new object that is a joint to goal. So it's a copy of this joint and it has a suffix goal. What does that exactly mean? So let's try moving our goal and we will see what it means. We'll just orbit the scene a little bit, and what if I pull this upwards a bit? You will see something happening. I believe I have my snapping on, yes, and you can see a very weird behavior, so don't forget to turn it off. And you can see something pretty interesting going on here. Let's try in this direction, and it sort of looks like an arm or a leg. What IK is, basically it's a complicated constraint. It will tell the joints in the chain to orient themselves, to rotate and follow and aim this one here. It's a really simplified explanation, but it will work for now. Let me undo that to default state, just like this. And just to prove you the role of the z-axis, let me select this joint and move it, and you will see there is no flipping happening here, no problems. Okay, we like the z-axis pointing downwards. So imagine this is a hand or a leg, and what if you want to have a control to animate the end position? So let's say this is a foot, and this joint number 2, this guy will always follow this goal. No matter where you put it, it will always follow it, and the rest of the chain will behave accordingly. It will try to mimic the limb. Let me do that to default position. I almost always color and give my objects some sort of a shape, especially my controller object. In this case, the goal object is a controller object. So here under object, I can give it some shapes, so something like circle, maybe this direction, and always color it. So use color here under basic, on, and select with some vivid color, something like this could work. And you can actually now see that null object. It won't render, but it will be visible in the viewport. So basically this IK chain guy mimics all the orientations and movements of these other joints as you would expect it. Otherwise, you would be forced to use forward kinematics. You should then rotate this guy. And let me just show you that. Here is a slider, so you can go to FK mode. And now to animate this, you should go here and rotate this guy, and then select this other guy and rotate it also, and so on and so forth. It's really tedious for some tasks, so let me undo that all. And I'll also go back here in the IK mode. So IK can take really a lot of work from your chest, and it can simplify things. But remember, animators love to have both IK and FK option on the same joint chain. This comes really easy in Cine4D with this IK-FK switch, and this switch has a 0 to 100%, so you can actually blend nice and fluent between them. As you saw, if we move this goal guy, you will see the bending will occur in this way, so like this. But what if we want it to appear differently? What if we want the bend to appear in this direction? Let me clear the doodle frame and undo the position of our guy here, our goal guy. And the answer comes through this IK tags pole vector guy. So if you click here on add pole, you will see joint pole was created. That's additional control. So let's now position this goal so we have an actual bending occurring and try to play with this pole guy. So let's pull it, let's say, here, and you can see it defines the direction where the bend will occur. This is really useful. So you can create straight chains and define with this pole vector guy where the bend occurs. If you create chains that are not straight, and Cinema is really smart enough, if you create a chain like this, it will assume this for a bend direction. You will not have to add a pole vector manually. I will also delete this doodle guy, and many of you will ask, so what's the big deal with these joint poles? Well, the goal object will always look at the joint pole. You have to tell this chain where do you want this bend to occur, where are the limits. So for example, let's try something like this. And here under IK tag, the axis that will point, and by default that's the y-axis, that is this green guy. So this green guy will always look at the joint goal. It will always point to this joint pole. So what happens once you, let's say, cross the line? You can see the flipping occurs, and actually this joint 2 points to the joint pole. So just zoom that a bit so you can actually see. You can see this green guy is always pointing or trying. It's hard to point to this pole vector. So watch what happens when I cross that imaginary plane. Watch what happens with the IK chain. It will flip, because now it has to reverse to be able to look properly in this joint pole. Well, some of you may think, okay, so let's pull it upwards a bit. That's a solution, but what if you need this guy to go all the way around? So it should go 360 degrees. So that's somewhat an extreme posing, but it can happen. We'll rather undo all that till we reach the 0 pose for our guy. Something like this, and this is the 0 pose. And you can now actually see the need for the reset position. It is really, really needed here. Let's do just that. I will select my joint goal, and here under coordinates I will freeze it all to have nice 0, 0, 0 values here. So let me freeze that all. And since I saved that script, I will go Window, Layout, Command Manager. I will type here reset position, and here it is. I will drag it here in the viewport and move it, let's say, here side. So if I move this anywhere in the scene and do a reset position, it will get back to that, let's say, home position. I almost always prefer building my pole vectors manually, so I will delete this guy. And if you have been asking yourself, why is there a conversion menu here, you will see how useful it is now. I will select this first joint and convert it to a null object, and I will use that null object as a pole vector. So simply take it out from the hierarchy here, Let me pull it somewhere aside of the character, oh, somewhere aside of this joint chain. And if I deselect it, you can see really a tiny dot here, and let's give it some shape, something like a circle. That will go to, it should be XZ, maybe 4 centimeters in diameter, until you find something that really pleases. You can choose whatever you want for representation here. And I will also give it a color. I believe this is the default color for pole vectors. You can use any you like, any you feel comfortable with. So I want to use one of these axes on this chain to point to this guy. So I will avoid flipping. So I will name this pole, and I will simply drop it here in the pole vector object slot. This will be my pole vector. And if I undo that, watch what happens with the axis. You can see it automatically chooses Y as an axis that will point to this guy. This green guy shows the plus direction, and there is an imaginary minus direction on the other side. Hope that makes sense. So I'll select a minus Y axis here, and my object, I will drag this object here, and you can now see that actually that Y minus points to this pole. I hope this is not too confusing, and there is a really good reason why I'm doing this, and hopefully my English will be good enough for you to understand. So now, as you can see, we have this problem. It always points and bends in this direction. So we would like to have it on the side, so we can be able to do a full circle without flipping, but also to bend in this direction. Okay? So there is a twist option here. So you can actually define where that bend will occur. So you can twist the chain, so 90 degrees is fine. So let's test that thing, how it works. Now you can actually see we can move all the way. Let me go to my side view and I will show you this. You can actually move it all the way around. You will have no popping, no flipping, and it still works. And of course, the reset position works also. I can really understand this can be a little bit intimidating at the start, but give yourself time. Breeding takes a lot of time, a lot of patience. So just for the sake of clarity, let's just once more briefly run through everything we did. So we created a simple joint chain. We aligned all those joints on the z-axis, so we decided that the z-axis points downwards the chain for the reasons we explained in the previous lessons. And we created a simple IK chain, so we can mimic a leg setup, for example, so it's easy to control. You have to control just one controller. And we created a reset position button, so we can reset that to 0. And here under pole vector, we told our joint chain to use our manually created pole. We offset it to the side of the chain and did a twist, so our imaginary leg in the knee can bend in the proper, in this way, this desired direction. And that's about it. Now when you create some sort of a rig, you want to have a flawless system. And that is what I always recommend you to do. Imagine what will you want to do with a character or with a setup, and see if you can do that before actually binding it to a mesh. That is really problematic, redoing the whole thing once again. So I suspect from experience that I will need to move the complete setup. And to move the complete setup, maybe I'll just take this root parent null and move it, and you will instantly see a problem. Let me undo that. The problem is that we want this goal and this pole vector to follow. So we want to have some sort of a controller to move the complete setup. In this particular setup, this is really simple. We will simply just create a joint goal and joint pole a child of that root null. This is our parent object. So now we can simply move that thing wherever we want and do that. And if we do a freeze transformation here, we can actually have a reset position for that guy. One thing that I also can notice is that the axis which points to this pole vector has changed because we made a child-parent relationship. Beware of that. Those are little tricky things that can really make you go insane, and also count the twist. So in this case you want suspect it's minus x. Yes, and that's the result we are looking for. So actually the minus y is pointing to our pole vector. Hopefully this is not overwhelming, not too complicated. It's simply the way it is. There is no way around it. So now we have somewhat of a closed setup. Our joint goal will reset always to its default position. And in this case it didn't, because we haven't freeze the transformation. Let me undo just that. Actually I want to freeze on this position, so we freeze all. And once you move this guy into reset position, it will snap back. It will do the same for this root. So let's move it anywhere in the scene we want to a reset position. So even if you move this guy and both joint goals somewhere, it will always reset in relation to this root parent. So now we have a closed system that actually works. One little thing you could add here is a reset rotation for this guy. So you have the ability to rotate this anywhere, any way you want, actually, this root guy. So you have a reset button for rotation. So if you had problems following this lesson, simply try to watch it a few times. These are really, really fundamental things. And the next lesson I will talk about IK and FK blending just a bit to clarify those two terms, and it will help you once again understand this IK system a little bit more.